This is fish throw up. It's remnants of a juvenile salmon's previous meal. Southeast Alaska is experiencing more rain in the summer, shifting the dynamics of watersheds. Based at the University of Alaska Southeast, researchers at the Alaska Coastal Rainforest Center are gathering data on how these high flow events impact juvenile salmon and Dolly Varden. How do juvenile salmon respond to storms? Graduate student Blake Toney hopes to answer this question by tracking their diet, growth, and movement through the Montana Creek Basin. To track their movement, a pit tag is placed in some of the fish. Similar to a dog's microchip, these tags, the size of a grain of rice, can help track their movements. When scanned, we can identify changes in the size and the diet of the tagged fish.
And then we're able to, when we recapture that same fish, pull its unique ID code and track things like its growth over time. You can see we insert the tag on the abdomen and there's not even really a scar on there. So this is probably an older tag. And we also have antennas that live in the creeks out here. So as a fish swims over the top of an antenna, we get a read on that individual tag number.
Back in the lab, they've collected over 400 samples of fish throw-up, currently identifying the organisms and invertebrates within. They hypothesize that juvenile fish escape into smaller tributaries during high flow events to conserve energy and feed on terrestrial invertebrates, like beetles and earthworms washed into streams.
What we're seeing here in Southeast Alaska is an increase in magnitude and frequency of these high flow events, and that's projected to be the trend here for the foreseeable future. And so as the climate is shifting and the conditions in the freshwater environment are shifting, we want to be able to have a sense of how that's going to affect populations of these species that are ecologically significant and also culturally and economically significant.